In this module, we are going to examine how we access Claude and use it to generate some text. To help you understand how this works, I'm going to walk you through the full lifecycle of a request to the Anthropic API. We are going to also take a brief look at what is going on behind the scenes inside of Claude. To get started with this walkthrough, we are going to consider a straightforward standard chatbot app. Let's imagine that you are building a web app and want to show a chat window to a user in the web browser. When the user enters a message and clicks send, their expectation is that some response will just magically appear. Now, like I said, I want to examine what is going on behind the scenes here to generate this text and display it on the screen. We are going to break this down into 5 separate steps, which I've outlined at the top of this diagram, and we're going to walk through each step one by one. When a user enters some text and clicks send, that text is going to be sent off to a server that you, the developer, implement. I mentioned this step just to make one thing clear. You should not attempt to access the Anthropic API directly from a web or mobile app. Whenever you make a request to the API, you are required to include a secret API key. And the best way to make sure that this key stays secret is by never including it inside of your client-side app and only making requests to the API through a server that you implement. On to step 2. Once your server has received a request from the client, the server will make a request directly to the Anthropic API. Usually, you'll make this request through one of the SDKs that Anthropic has published. There are official SDK implementations for Python, TypeScript, JavaScript, Go, and Ruby. Now, you don't have to use an SDK if you don't want to. You can also make a plain HTTP request if you wish. When you make this request, you are required to pass along several pieces of data. In particular, you need to include an API key, the name of the model you wish to run, a list of messages, which will include the text that your user submitted, and a max tokens value, which limits the length of the text that Claude will generate. Next up is the Anthropic API, which is where our text will actually be generated. This is where we are going to go into a little bit of detail on the text generation process within the language model. This process is complex, so I'm going to give you a simplified, high-level overview. We are going to break down the text generation process into 4 separate stages. In the first stage, the user's input will be broken down into smaller strings. Each of these text chunks are referred to as a token. These tokens can be whole words, or a part of word, or even a space or a symbol. To keep things clear, we are going to assume that each word forms one single token. Each token is then converted into an embedding. An embedding is a long list of numbers, and you can think of these lists as being like a number-based definition of a given word. Now, an interesting aspect of written language is that a single word can have many possible meanings, and it is only the word's position in a sentence and presence of other words around it that narrows the definition down to one particular meaning. For example, quantum is a word that has many different definitions, and when we see this word, we don't really know what it means until we see other words around it. Likewise, each embedding can be thought of as containing all possible meanings of each word. To refine each embedding down to a single precise definition, a process known as contextualization is used. In contextualization, each embedding is adjusted based upon other embeddings around it. This process helps highlight the meaning of each embedding that makes the most sense given its neighbors. The last step is generation, which is where the text actually gets written. By this point, each of the embeddings has absorbed a tremendous amount of information from their neighbors. The final processed embeddings are then passed to an output layer, which produces probabilities for each possible next word. Now, the model doesn't automatically pick the highest probability. Instead, it uses a mix of probability and randomness to select words, which helps create more natural and varied responses. The selected word is then added on to the end of our list of embeddings, and the entire process repeats itself all over. After generating each output token, the model will then pause and ask itself several questions to decide if it is done generating text. First, it will count the number of tokens it has generated and see if it is larger than the max tokens parameter that was provided with the input request. This max tokens parameter will limit the total number of tokens that the model will generate. There is also a special end of sequence token that the model can generate. This is not a regular word. It is a special signal that the model uses to indicate that it has reached what it considers to be a natural end to its generation and that it should stop. Once the generation is complete, the API will send a response back to your server. The response will contain a message, which has the generated text inside of it, along with usage and stop reason. The usage is a count of the number of tokens that you fed into the model and the number of tokens that were generated. The stop reason will tell you exactly why the model decided to stop generating text, whether it hits a natural end of sequence token or maybe it exceeded the allotted number of tokens. Once your server has received this response, it will send the generated text back to your web or mobile app, where you will display it on the screen. So that is the entire flow. Now, we covered many topics in this video. I don't expect you to memorize any of this just yet. The only goal is to start to get you familiar with some common terminology around accessing Claude through the API.